let's do some examples. If the probability that South Florida will be hit by a major hurricane, that's category 4 or 5, in any single year is 1/16th. We're going to use P of H equals 1/16th for that event of a major hurricane. So are these yearly major hurricane events independent or dependent events? Well, these are independent. If you get a hurricane one year, that doesn't guarantee that you're not going to get a hurricane in the next year, or vice versa. Each year's hurricane paths are going to be independent of the previous year. So what is the probability that South Florida will be hit by a major hurricane in 3 consecutive years? Now, because we have the independent events, when I'm trying to find the probability of the event hurricane happening in the first year, and we'll say H in the second year, and H in the third year, I'm going to just simply multiply probability of H times probability of H times probability of H. And probability of H is 1/16th times 1/16th times 1/16th. I don't have to worry about given that something's going to happen the year before because they're independent. When I multiply this out, the numerator is easy. 1 times 1 times 1 is 1. And 16 times 16 times 16, you might want to get a calculator out for that, is 1 over 4,096. Okay, so what is the probability that South Florida will not be hit by a major hurricane in the next 3 years? So I have to first figure out what the probability of not a hurricane in 1 year is. Well, because the probability of H is 1/16th, probability of not H is 1 minus 1/16th, which we worked out to have a common denominator of 16. So we have 16 over 16 minus 1 over 16. That's going to be 15 over 16. So the probability of not H is 15/16. So now I'm trying to find out what's going to happen will not be hit by a hurricane in the next 3 years. So we have probability of not H, which is independent of the next year, which is the probability of not H, times the third year probability of not H. So we have 15/16 times 15/16 times 15/16. The denominator is still going to be 4,096, and you might want to get a calculator out, but it's going to turn out to be 3,375 over 4,096, and this does not reduce. Our last question is a little bit trickier. What's the probability that South Florida will be hit by a major hurricane at least once in the next 3 years? Now, we haven't ever done anything that says at least once, okay? The probability that we did on Part B was that it will be hit every year for 3 years. Part C was, well, won't be hit every year for 3 years. But if we have just at least once, that means we only need one hurricane over the 3 years to satisfy this probability event. So we have a little hint here. The probability of an event happening at least once is 1 minus the probability the event does not happen. Now we've already figured out that probability that South Florida will not be hit by a major hurricane in the next 3 years. We've already figured that out in Part D. So if I'm trying to find the probability of a hurricane at least once in 3 years, I'm going to take 1 minus the probability of not a hurricane in 3 years, which happens to be the answer to Part C. So I'm going to take 1 minus my answer to Part C, because we know that Part C is it didn't ever happen. So if it happens once or twice or even all 3 times, that's going to be the complement of that. So one easy way to get a common denominator is just take the denominator that you want over itself to replace the 1. And when I subtract that, I'm getting 721 over 4,096. is the probability that it will happen at least once. Now, if you want to put some context into these fractions, 1 out of 4,096 for part B turns out to be 0.00024. So that's very unlikely that we're going to have a hurricane 3 years in a row. What's the probability that you won't have a hurricane 3 years in a row for part C? If you divide that out, we have 0.8239. So it's actually fairly likely, so it's 0.82, it's pretty close to 1, that you're not going to be hit by a major hurricane in the next 3 years. For part D, 721 out of 4,096 is going to be 0.176. So 0.176 is fairly close to, is closer to 0 than it is to 1, so the likelihood is low that you're going to have a major hurricane at least once in the next 3 years. Our next example, you're dealt one card from a 52 card deck. Then you're dealt a second card from the same deck without replacing the first card. Without replacing. So because we are not replacing, that tells me that these are dependent events. The second card pull changes depending on what you pilled on the first card. So we're trying to find what is the probability that 2 kings are pulled. So we have the probability of a king and then another king is equal to the probability of king for the first pull times the probability of a king given a king was already pulled. So the probability of getting one king for the first pull is 4 out of 52. Okay, you have 4 kings in your deck of 52 cards for the first pull. But on the second pull, you actually took out one of those kings. So now you actually only have 3 kings out of how many total cards? Only 51 cards. So we have 3 kings out of 51, given that the king was already pulled on the first one. So when I multiply this out, I'm getting 12 over 2,652, which if I divide the top by 12 and the bottom by 12, that gets me 1 out of 221. All right, our next problem. What is the probability that a heart card is pulled first and then a red card? So I have the probability of heart and then red. We have the probability of heart, I'm just going to use H, times the probability of red, given that the heart was already pulled. Okay, now these are a little bit trickier because hearts are also red. So let's see, how many hearts do I have? There are 13 hearts out of 52 cards. Now, what's the probability of red given that a heart was already pulled? Okay, so we have 13 hearts out of 52 for the first pull. But then you actually pulled out a heart. So now we have 12 hearts left out of 51, but we're actually talking about red. How many other red cards do we have? Well, we have 13 diamonds, and that's also red, right? So the first time we had 13 hearts out of 52, and then the second time we only have 51 cards, but I have how many reds? Well, I have 13 diamonds plus another 12 hearts, and that gives me actually 25 red cards out of 51 possibilities. Normally it's 26 out of 52, but because I already pulled a heart, which I know a heart is red, I'm only left with 25 out of 51. When I multiply these, I'm getting 325 in the numerator, 2,652 in the denominator. When I divide by 13 in the numerator and denominator, that gets me 25 out of 204, which is my answer. Cannot be reduced anymore. And then our last problem for this example, what is the probability that a jack is pulled and then a queen? So that means we're going to do probability of jack times probability of queen given the jack was already pulled. Okay, so let's see. I have 4 jacks out of 52, and that is for my first pull. So 4 out of 52. Now, once you take out one of those jacks, my new question is how many queens do I have? Well, if I took a jack out, that doesn't actually change how many queens there are. There's still 4 queens left in there. But how many total cards do we have left? Only 51 now. So although the numerator didn't change this time, the denominator still changes because we still don't have 52 cards, we only have 51. When I multiply my numerators, I'm getting 16. When I multiply my denominators, that's 2,652. I'm going to divide the numerator and the denominator both by 4, which gets me 4 out of 663, which is the final answer.